Today we will be presenting a case study that portrays an offshore scenario and compare it with a range of parameters. Our fictitious deepwater rig, Tortuga, is located in the Gulf of Mexico and is currently undeveloped. We are given depths and distances that allow us to create a layout of the entire subsea system. By plotting these points, we have made a layout of the platform connecting to the manifold and wellheads through a dual line. As it reaches the seabed, both wells deviate at about 4 degrees before it reaches the reservoir. Here are our given parameters that will be applied to the base case or control variable. We will use this to compare each scenario and note the discrepancies in annual flow rate. The following assumptions were made for the sake of stable calculations. The reservoirs in the Tortuga contain heavy black oil and are 100% recoverable. When calculating for cumulative production, we assume the entire year maintains constant daily production.
With the use of PipeSim, these different sets of parameters will be used to compare with the base case for 10 years in terms of IPR curves, production, and life of wells. There were some assumptions and variables that needed to be calculated, such as external radius, compressibility, viscosity, and pseudo-steady time. We began modeling our base case well as pictured on top, but realized that it played out two completely different production systems. In the end, we modeled one well and took into account both wells through our calculations by multiplying production by 2. Since we were given a reservoir pressure decline, we can calculate the initial pressure for the following year and plug it into PipeSim to run through the nodal analysis and give us the new flow rate. This new flow rate will be plugged into the following equation and will be given a new pressure that we can input into the next year. This process continued for 10 years worth of data. In our pressure profile, we are able to see the dramatic decrease in pressure once it enters the choke and into the separator. We can also see it passing through the bubble point pressure of 4,800 psi. For our base case, we can see that our initial production starts at 2,003 stock tank barrels per day and falls to 1,018 stock tank barrels after 10 years. We'll use this data to compare to other scenarios. As you can see here, this is our IPR for our 10 years of our base case. This is our TPR. These are our zoomed in IPR curves. We start at 2003 stock tank barrels and we decline down to 1018. As you can see here, this is our base case cumulative production. We run out of our 5 million reservoir barrels around 3.6 years. Very fine looking graph here. This graph shows inflow performance rate, or IPR, drop over 10 years for our base case. This blue line right here is our initial production for the first year, and so on and so forth till we get to our 10 years at the very bottom here. This is our first varied parameter case that we chose. We set our separator pressure at 5,000. As you can see, we unconverge here due to the fact that our pressure drop is too much and we cannot have enough flow. As you can see, we also do not hit our 5 million barrels, so that means we do not deplete our entire reservoir. We also die at 6 years, which is almost twice our base case.
On this graph, we are able to visually compare the cumulative production and conclude that our base case has a faster production than the higher separator pressure case. When we adjusted our choke to a higher position of ½ inch, we produce much quicker than our base case. There is higher flow rate, which leads to a well life of 0.89 years, or less than 11 months. On the other hand, for our lower choke position case, it is quite the opposite. There are lower flow rates that require a longer drainage life of 14.3 years. On this graph, we can compare all three cases and conclude that the choke position of 3264 relieves the fastest flow rate. When it came down to comparing different wellbore inner diameters, some additional adjusting was required. The thicknesses of the wall had to be modified to fit the pipe stem model. For the inner diameter of 60 inches, we changed casing thickness to 5 inches. This case of higher inner diameter gave us a well life of 3.69 years. As for lower inner diameter, we have adjusted the casing thickness to 1 inch. This creates smaller area, which creates faster flow and shorter drainage life. The life of this lower wellbore diameter is 3.68 years. In the case of our perforated well, we have come up with some parameters that were needed in PipeSim in order to run our nodal analysis.
In this graph, we can note that our initial production for the perforated well is very low in comparison to the other sets of parameters. It starts at 1,273 stock tank barrels per day and has a well life of under 6 years. Here's our inclined well parameters. As you can see, we start up at the top and it slowly deviates to an 8.47 degrees, and then around 10,100 feet we deviate to 60 degrees with a total displacement of 68.7 degrees. For our inclined well case, as you can see, we ran out of our 5 million reservoir barrels around 3.47 years. This is our comparison graph with our base case, inclined well, and perforated well. As you can see, our inclined well runs out the first, followed by our base case, and almost double those times comes in our perforated well at 6 years. Our inclined well runs out at 5 million right here.
With our base case, we are able to have an idea on what to look for in different production rates and life of our wells. We have set up several different parameters for these comparisons, such as higher and lower separator pressures, choke positions, wellbore inner diameters, perforated and inclined wells. When comparing our base case to simulated scenarios, there is a distinctive difference in life of wells. The order of well life is inclined, base case, and perforated, in that respective order. As for changes in separator pressure, when attempting to aim for a lower pressure, the flow rate did not vary more than a few decimal places in comparison to the base case. However, when increasing our pressure to 5,000 psi, our time to produce initial reserves is 6 years. This will take longer than our base case of 3.68 years. A change in wellbore inner diameter slightly affects the time of producing our initial reserves. We can see that for a lower ID, it is 3.68 years, and for a higher ID, it is 3.67 years. The second most significant change in production time is with the applied change in choke position. When choke position is lowered, there is 14.3 years to produce our initial reserves. With there being more air to flow through, the production will go by quicker.
If we were looking to choose one of these methods for efficient and quicker production, it would be the higher inclined well. If we were to combine both the higher incline and perforated well, we potentially could increase life and productivity. A reason we should have a longer life is so that we do not ruin our reservoir pressures. If we can control our reservoir pressures, the potential production rate can increase. The reason we did not choose the choke increase was due to the fact that it could potentially have more than 5 million barrels. We would not have efficiently extracted the reservoir and would be wasting money. And here are our references. Thank you so much for spending some time and watching our video, and I hope you have a nice day.
That's a wrap.